Good morning everyone, hope you're all well. Today we're going to cover disk recovery. So we've spoken about all these wonderful RAID levels and how resilient they are and how life's fabulous because nothing's ever going to go wrong. But things do go wrong and we might well lose a disk, so that's what we're going to do. First of all, start with a clean sheet, 5 disks, not under volume control. Then we're going to create a new volume group and a 5-disk RAID5 volume. Actually, this would basically apply if we created a mirror or RAID10 or RAID6, but I've only got 5 disks, so I thought RAID5 probably makes most sense with those, which is cool. We will then put a file system on it, we will mount it, and we'll copy some data into this new volume so that we can then test just whether or not this is resilient in the event of a disk failure. Then next, and actually this made me slightly nervous because I'm using a Chinese sort of badge engineered 5-disk array from a company called Yachtermaster. I actually bought arrays off them before, but this one's different in that I'm pretty sure it's hot swappable, but it's got no labels on it, nothing. In fact, it doesn't even say Yachtermaster, where I've got 5 arrays on Kukang, the machine that we've used a few times, from Yachtermaster, and I found out they are not hot swappable. And when I tried to swap an 18 terabyte disk, when I put it back in again, it blew up. So do be careful at home. If you have an array, make sure it does support hot swap. That's what we're going to do. Anyway, then we're going to have a look around, see what we're told. So let's see what kind of error messages we get and what our RAID5 volume looks like. Not very well, I imagine. Then next we'll pop in a replacement disk, and then we will recover the RAID5 volume and validate that the recovery was in fact successful by trying to recover data from it, etc., etc. So that is the master plan, and hopefully after we've done that, hopefully everyone will live happily ever after. Okay, so let's do it. I've actually decided I'm going to create 2 volumes because I want to demonstrate 2 different procedures for recovering failed logical volumes. So we've got 2 to break, that'll be more exciting. So what I've done is I've created a script, and this script will create everything for us. In fact, let me just quickly go through it very quickly. First of all, do a wipe fs to make sure that actually all 5 disks are completely scrubbed of any information. They're not in logical volume manager control, etc., etc. Then we're going to do a VG create, but in fact I just wanted to show you that you can do a VG create and initialize the disks at the same time. So that's what the next line does. The actual commands are all in green, or predominantly in green. We're going to create a 5-way RAID, so an LV create -- type RAID5, stripes 4 because there are 5 disks. You always have to put 1 less with RAID5. Size 32 gig, well, just an arbitrary size, and a name R5vol, and we're putting it in data VG. Then we're going to create a RAID10 volume, so it's -- type RAID10, stripes 2 because we're creating a 2-way mirror, but it's going to use 4 disks. So what we're actually going to have is 2 striped mirrors. Therefore, number of stripes is 2. The size is 10 gig. The name is R10vol. It's in data VG. Then this next bit just simply is a for loop. So it will go around the loop twice, setting the variable LV. First iteration, it will set the variable to R5vol. The second iteration, it will set it to R10vol. So it's going to make a file system of type ext4 in /data VG of whichever volume's in that variable. Then it's going to make a directory by the same name. Then it's going to mount the volume onto that directory. So that's cool. Then finally, just so that we can verify that when we break it, because both of those are resilient volumes, when we break it, that in fact our data is still intact. And the simplest way to do that is actually to find ourselves a text file and try and cat it, which means, and preferably one way down the directory structure that we've copied into that volume. And if we can cat that file, then we've descended a number of directories, and at the same time we've opened a file and displayed its contents. Well, if we can do that after we've pulled a disk from the array, then I'd say that that was a sign that this was a resilient volume. And that's all the script does. So let's quit out. Next thing we need to do is make it executable. And the next thing we need to do is run it. Here we go. Oh, didn't expect any interaction. Of course, it's complaining these disks have been used before, and it's found a file system, what appears to be a file system on the volume. So we'll say, yeah, wipe it. And of course, same again. It's now making the file systems. And of course, now it's doing the find piped into CPIO, which will probably take a few minutes. So I will definitely pause now. This is taking a lot longer than I expected. Aha, as I suspected. It is actually a lot more than a few hundred megabytes. It's 1.8 gigabytes, but that's fine. So we now have, let me clear the screen. We now have our two volumes in our volume group data VG. So we now have two volumes that are ripe for breaking. So that's going to be the next exciting part of this session. Let's actually go ahead and break these volumes. This is the fun part. It's always fun to break things. It must be the child still in me, just lingering somewhere in the background. Okay, I've had a lot of fun just preparing for this because obviously, as I've said before, I do at least try and make sure that what I'm going to do works. And then 90% of the time it doesn't actually quite as I meant, but that's okay. We can live with that. I'm really impressed with LVM because I tried desperately to confuse and break it, and it just survived. It just carried on quite happily and said, yeah, okay. Also, using a USB disk array creates problems that you quite simply wouldn't have with SATA and SAS setups. But we'll see, because what I plan to do is actually break the thing now, as we said. So first of all, quickly check that everything looks right, especially seeing as I have been playing with it. So we've got 5 disks, well, 6 disks, but in data VG we've got 5 disks under logical volume manager control, as we can see, B through F. If we do an LVS, we've got our 2 volumes that we created. And if we look at field 9, I keep saying, that we really need to go over these because it's very simple, but this isn't the time. But field 9 is the state of this device. And if it's a hyphen, it basically means, as far as LVM is concerned, everything is nominal in the famous sort of space type terminology. Yeah, all systems nominal. Okay, so there you go. Pardon my attempt at trying to do an American accent. Never been very good at accents. Right, so let's also do an LSBLK. Remember, LSBLK starts to get confusing when you've got a lot of volumes. But if we look down it, the point I'd like to make is that we've got our 10 vol on 4 of the disks. We have our meta sub volume, for want of a better word, which is like our housekeeping volume, and that's 4 megabytes. Okay, so that's very small. And then we have our image volume, and our image volume is actually where the data is stored. Okay, so remember, this is it's a RAID 10, and it's 2 disks wide, 2 mirrors, 2 stripes per mirror. There you go. So we can see our 2 stripes because we've got an image, of course, is the data. That's the actual data. Okay. Now also we can see exactly the same thing for R5. So we've got our meta device, which is 4 megabytes. We've got our image device. Now our meta device does not contain the parity. Inside the image volume, there is the data that you've put there plus any parity data. Okay, so we can see that R5 is on all 5 volumes, and this is actually why I plan to break SDF, because I don't particularly want to break the mirror at the moment. That's the plan. All right, So here's SDF, and it's got data VGR5 vol, the meta device 4 megabytes, and it's got the image, which is the 8 gigabytes. Now, how can we break it? Well, at first I was just popping the disk out, and of course that breaks it, and it confuses Linux, but Linux never quite gets over it, but Logical Volume Manager does, as I will demonstrate in a minute. So, like I say, very impressed with Logical Volume Manager. But then I thought, well, we could do it a slightly different way. We could, let me clear the screen for clarity, we could do a wipe FS. We will pop the disk, by the way, so we will end up with Linux getting confused. But we could do a wipe FS. You could do -a, but, you know, hyphen all. So wipe, and by that, it doesn't mean wipe FS, all disks. It means all magic data, all special data on a particular disk. So we can say on /dev/SDF, which was the 8 terabyte. Do I keep saying 8 gigabytes? It's an 8 terabyte drive. Okay. And it says no. It's part of a mounted volume. It's part of a volume, and it's part, not only that, it's part of a mounted volume. So it won't let us do it. Okay, so what we can do is we can say hyphen force. So we can say, you must do it. I'm telling you to do it. I want you to kill that disk. Okay, and this time it's done it. All right, it has actually broken that disk. So if we now do an LVS, it's complaining, quite obviously, because now it says, hang on a minute, one of the disks that I had has disappeared, or something funny's gone wrong with it. And now if we look at R5 vol, and if we look at this point here, field 9, we can see that it's got a P there for partial. Okay, so it means it's partially there. Right, the data and everything is fine, okay? But the data and everything is fine, but we are no longer resilient. That's RAID 5 for you. If it was RAID 6, we'd still be resilient. Now, if you recall, under /R5 vol, we should find loads of directories. So if we went, for instance, let's drill down a bit to lib, and if we went into, I think there's a directory called Python, well, there should be one for Python 3 exactly down there. Okay, and if we go down a bit further, now if I run file on there, I'm looking, yeah, there we go. I was looking for an ASCII text file. I want to actually open a file. So let's open that file. It's got some text in it and it's worked. So why have I just done that? Well, just to prove it's still working. Okay, df-h, and we can see that it's still mounted, but it's most definitely broken. If we do a PVS, if you look at the bottom, it actually says unknown data VG. It's sort of like, where's that 8 terabyte drive gone? It's vaporized, it's disappeared. Okay, so we've broken it. Okay, by wiping it, we've broken it. Although, remember, we're in danger now. If we lose one of those remaining disks, we've lost our data. But at the moment, we're okay. So now the exciting bit. We're going to actually pull a disk from the array and see what happens. So let me clear the screen. We're going to do a demerge -W. The W, I think, stands for wait, but basically that will display the latest system messages, and the W says and wait in case any more appear. So we're going to pull the disk. So pull the disk. I've got a brand new, he lied, disk, another 8 terabyte drive that I'm going to put in place of the one that we're going to pop out. And I'm just hoping, because every disk has a UUID, okay, a unique universal identifier, and I'm hoping that LVM isn't going to sort of see this disk and say, oh, I've seen this one before. By the way, just to confuse the issue, every physical volume has a unique universal ID. Every logical volume has a unique universal ID, as does every volume group, and it is possible to change them, by the way. So I'm just hoping we don't have issues. It's dead easy to fix. You can literally do a VG change -u device name, and then, VG change -u volume group, and it will actually change the unique ID for that volume group. So it's possible to get round it. The unique Yeah, it's always a mouthful. The UUID, that's easier. The Unique Universal ID is a 128-bit signature, for want of a better word, which uniquely identifies this device. And with 128 bits, it doesn't sound much, it's only 128 bits, but if you were to create 1 billion new UUIDs a second, it would take longer than the universe has existed before you run out of UUIDs with 128 bits. Okay, 2 to the 128. It's a lot. Okay, so I'm now going to pop that disk. So wait for the explosion. There we go. Oh, it's failed. There's a surprise. One thing I should point out is that this USB enclosure, when you pull a disk, then the whole thing goes offline. So that is going to confuse both Linux. I was going to say both Linux and LVM. LVM will see that everything's changed, but it won't be confused. So you can see there that drive B, drive C, drive D, drive E, and drive F have all gone offline. And they've come back, which is good. Well, 4 disks have come back. Hardly surprising. 4 disks have come back, but notice they have new drive letters. So Linux thinks they're new disks, whereas Logical Volume Manager just looks at the metadata and says, oh, okay, and it's perfectly happy. So I'm going to pause the recording while I pop this disk out of the tray and actually put the new one in. Then we'll put that back in. So see you in a second. Right, I've swapped the disk across, so I'm now going to put it back into the 5-disk array. So here we go. It's really awkward actually. There we go. And hit enter a couple of times. And we can see I didn't hit enter quick enough. Those messages just below where it says attached SCSI device is from when I've just plugged that disk in, because it's disconnected the array again, and it will now hopefully recover reasonably quickly. There we go. And now if we look at the bottom, we've got 1, 2, 3, 4, 5 disks, and it's the disks that we can see are SDK through SDG, so they have changed. Right, so let's have a little look around and see what it is that we can see now. So, well, first of all, we've put the disk back in. First of all, let's do a PVS and see if anything's changed. And, okay, notice that it's got SDG, SDH, SDI and SDJ, whereas before it was B through F, but of course F is the one we broke. But it has the unknown device that we saw earlier, so we need to fix that. If we do an LVS, we still have a P because it's a partial disk. That's good actually, because that means that the disk which I wiped and scrubbed and really bashed about has not been recognised by Logical Volume Manager as previously having been part of our 5-volt, which it had actually. In my experiments and things, I'd used it before. So that's good. If it recognised it and thought there was valid data on there, it would have an R where the P is. So instead of P for partial, it would be R for refresh. In other words, it would say, oh, all we need to do is resync this device because it's the same device, it just went missing for a while. So now it's come back. If we resync it, everything will be fine. So that's good. So what we need to do though is we need to fix this unknown device here. Okay, so that's the first thing we should do, and we could have done this before we popped the disk. It says unknown and it said it before we replaced the disk drive. Now to do that we need to say VG reduce. So we do a VG reduce and we say VG reduce volume group device name. So you would put VG reduce volume group data VG /dev/SDF. Well, the problem is it says unknown, so we can't use /dev/SDF because it doesn't even know about it, and anyway they've all changed. So what we can use is -- remove missing. So VG reduce -- remove missing, and chances are even this won't work, but let's try. There are still partial LVs in the VG group. To remove them unconditionally, you've got to use force. So all we need to do is add the force, say back to our, come on dude, this is my computer, I want you to remove this missing disk and I will accept the consequences, is really why it's there. It's making you think about it. Is this okay? Well, we know it's okay. We know the disk that was originally in there has been removed, so we will hit that, and again it comes up with loads of messages, but right at the bottom it said wrote out consistent volume group data, which is good news. So if we do a PVS now, the unknown has disappeared, and that's really good news. Okay, so what we need to do now is actually add the replace disk. So if we do an ls of /dev/sd question mark, we will be able to see that the five disks consist of SDG through SDK, which appeared in the demers, by the way. So what we do is a pv create /dev/SDK, and that will bring SDK under Volume Manager control. Okay, so it's actually noticed that I have used this disk before, despite me pretending it's brand new. And there's been a file system on it, so we've accepted that. We say, yeah, just overwrite it. That's not a problem. So now if we do a PVS, we can see that we actually have 5 disks. But notice dev SDK is not in data VG. So the next thing we need to do is a VG extend, and we need to say data VG /dev/SDK. And now if we go back and do our PVS again, we can see that SDK is part of the data VG group. Now we want to repair it. Okay, so we've got our additional disk, but we want to repair our volume, our 5 volt, which we know is damaged. And to do that, we use a command which is used for lots of things. For example, if you had a linear, in other words, non-resilient volume, a simple volume, you could make it resilient by adding a mirror to it and converting it into a mirror. And the command you would use is LV convert. But we also use it to fix problems or to do repairs. We can then use data VG R5 volt. And it says, do you want to resync it? Remember, that's what the R stands for: refresh, resync, repair, repairable. Well, it wasn't happy with that. LV reconvert. So if we see if we can force it, and it failed. And what I've learned from experience is that I do need to reboot this system. Okay, we always try and avoid rebooting, but there comes a point where we have to reboot. So let's reboot. Okay, I'll switch across to HDMI. We're just about there. Okay, I did edit that slightly because it takes a few minutes to, well, it's the USB disks always take quite a while to get sorted. Right, so if we come back here, go back onto Tempest, become root, clear the screen, rerun the repair command. We probably don't need the -- force. I put that in because I was hoping it might work, but from experience I'm pretty much sure it wasn't going to. And let's see, faulty device successfully replaced. Okay, so I don't understand why you need to reboot. I think it's simply because all the drive letters changed. I think it was just LVM. I keep saying LVM can handle it, but I think at some point he gets confused, in fairness. And so now it, hopefully, if we do an LVS, our driver failure letter has disappeared, and it is now hunky-dory. So that's all good news. Well, what we're going to do now is I have actually deleted the RAID5 volume. The reason I did that is I wanted a completely free disk. So by getting rid of our 5 volt, we now have /dev/SDF. We didn't actually need to do that for what we're about to do, but I just thought it would, there's so much clutter and information with all these volumes we've been playing with. I thought I'd just keep it nice and clean. And we've got a mirror. It's our 2 stripes. It's a 2-way mirror, which each mirror consists of 2 striped mirrors. There's actually striped mirrors are the hardest to put into words, but so that's what we've got left. So that's using 4 disks. we're going to pretend that one of those disks is flaky. Now, how did we know it was flaky? Well, but obviously we're getting error messages, but where are they? Well, the obvious place is either in var log syslog or in journal CTL output, or the journaling system, the logging system, which I'm going to cover because it's fascinating and very, very powerful. So I'm going to do a video on that. So first of all, what is smart? Smart is this self-monitoring. I forgot what it stands for, but the tool that the package we install is called Smart Mon Tools. So if we start off by doing apt info smart mon tools, control and monitor storage systems using smart. So that's what it is. Okay. So I already have it installed. How do you install it? You type, instead of apt info smart tools, smartmon tools, you type apt install smartmon tools. Okay. Then how do I actually look at any output? Well, my preferred way would be to do this, and that's to use journal CTL. I want to go to the end because I'm interested in the latest errors, so -e. And then U stands for unit, and the unit is whatever it is you want to look at. So that can be the hardest thing to figure out, what's the actual name. But in this case, it's really simple because it's Smart Mon Tools. So we say journal CTL -EU Smart Mon Tools. Okay, and if we look, it comes up, we're effectively in more. Okay, so we can do things like B for back, so we can go back through history, and we can see an error there. Smart D dev SDB no ATA check power status. By the way, notice it's going off the right hand side of the screen. So press right arrow and it'll all go across. So it's very friendly. Just play with it, and like I say, we will do a video later. But that's what it's good for. So I'm pressing spacebar now, and we're moving back through towards the end of the file. So it's reporting lots of temperature information, etc., etc. So SmartMon Tools, take a look at it. Right. So you've got that installed. Let's pretend. Okay. You've got the two-way mirror, which consists of 4 disks, because it's 2 striped mirrors in each of the mirrors that we've created. And we're going to pretend that SDD, and that's an arbitrary choice, I'll change it if you want, just say, we'll pretend that SDD is throwing up errors in SmartMon Tools, but it's still running, okay? And that's quite common, actually, to see a disk flaky. It's beginning to show signs of problems. So what do we do? So first thing we need to do is we need a spare disk. Oh, look, we've got SDF. Actually, we only need spare space, because what it does is it moves the extents. If we're going to move SDD, it moves the extents, in other words, the in-use data from SDD to wherever you tell it to go. So as long as there's enough space, you can move it anywhere. But we're going to just say move it to SDF. Okay, so what do we do? First of all, we've got to pvcreate /dev/SDF. So we have to put it under Logical Volume Manager control, which has succeeded. We then need to add it to data VG, because our mirror's in data VG. So we do a VG extend, okay, /dev/SDF into data VG. We've seen all these before, so nothing really, but in fact, most of this is just so simple. Okay, no device found for data VG. Oh, I like to leave my mistakes in for your benefit, because that's the sort of very easy to make mistake. I've just got the arguments the wrong way around. VG extend data VG SDF. So now if we do a VGS, we'll see that, if we do a PVS, we'll see that SDF is a member of the volume group data VG, which is exciting. So now we've got a disk available to us. So all we do is we move SDD onto SDF. Okay, so we say pvmove /dev/SDD/dev. Okay, now it doesn't move everything, it just moves the extents, that's all. Okay, so it just moves in-use extents. So if you've used the entire disk, then it moves everything, but if you've only used a small part of it, then it only moves a small part of it. That's why it's surprising. Well, I say surprisingly quick. I mean, it doesn't. That's a 3 terabyte drive. It doesn't move 3 terabytes, so it'll be reasonably quick. But I probably will fast forward it. Okay, that took a couple of minutes. That's all. It always surprised me how quick it is actually. But there you go. So pvmove. So now if we do an lsblk, we can see that SDD is now unused and SDF has our 10 vol on it. So there you go. It was that simple. But what we should do for completeness is we've got a faulty disk. So we should do a VG reduce data VG /dev/SDD. So we want to take that disk out now because we're going to go and fix it and replace it with a working disk. Okay, so now if we do a PVS, the disk is and then we should do a PV remove of /dev/SDD. And then if we do a PVS, we can see that it's actually gone. So we can now remove it. We can pop it out of our hot swappable. Do check that yours are hot swappable, but we could take that disk out, physically replace it. And then if we wanted to, we could PV move the data back on again. Okay, so if you've got free space, you can temporarily move a volume while you replace a disk. So it's really cool and really simple. And that is it, honestly. Well, I hope you enjoyed that short session on doing repairs to Logical Volume Manager. And as you've just seen, it's surprisingly easy. Of course, I'm sure there are edge cases that create more problems and are more difficult, but hopefully it's given you a good grounding and you can move on from there. Right, what I would like to ask is if you could do me a favour and leave comments about any topics you would like me to cover. I'm thinking about doing log rotate. I'm thinking about doing journal CTL or the journal logging mechanism. But what I really want to do is cover things that people actually want to see. So appreciate that. And also don't forget to like and subscribe. But the chances of you having got this far without previously having liked and subscribed are probably fairly remote, but still it's worth a try. Okay, guys. Thank you for your time and see you on the next one. Just for your delectation, here are 7 of my little mini PCs that I use. They're really good, actually. It's surprising how powerful they are. The bottom 4 are the ones I used for our Proxmox cluster. The Think Center is what we used for Proxmox backup server. The one above that is Tempest that we're currently using at the moment. And the one above that I'm not using yet. And then that little box above that is a 5 HDMI to 1 hub, for want of a better name, which allows me to switch between the different servers. On the right hand side is a 5 disk array.